we've been doing the subject called exponents, and we basically spoke about how to multiply exponents in previous lessons. And the one law we spoke about said, look, if we have the same base and we multiply, we can simply add the powers. So that would be the variable example. If you look at this using numbers, it says the moment you see these lovely bases being the same, instead of having to write everything out in full, what you can do is you write the base, you add the powers, and you get that as the answer. The other thing we said was what happens if you have powers next to powers, so powers to powers. It was a bit strange. And what we saw from just practicing in the last lesson is actually you can simply just multiply the two powers together. In terms of numbers, it would look something like, if we had that, what that means is to repeat that thing below 3 times, but after a while you start to spot this pattern and you'll see that you can write that as 2 to the 15. So that was the previous lessons. Now today, we're going to start to talk about what happens if we have something like that, or sometimes it's written something like that. When we're dividing exponents, we're dividing numbers that are in exponential form, but they have the same base, but now we are dividing. That's going to be the main focus today. So what we're going to do is we're going to start with a couple of examples. I'm going to show you how I would handle this, and then you're going to work from there afterwards. So I'm going to start with this one, and I'm going to do it. Now, if I have to write out, now I know this is frustrating, but 5 to the 8, just to give you a sense of why this notation is so glorious. Imagine if I had to write out 5 to the, you multiply 8 times, I had to do this every time. Oh, I think I'd change my job to a different job. So what we have here is, I'm going to show you how you handle this. And really what we see is that if you're dividing numbers that are in exponential form, the bases are the same. For each one on top, you can essentially say, well, 5 over 5 is 1, 5 over 5 is 1, and whenever there's one on top that's the same, essentially they're equivalent to 1. And so what I'm going to get left here, I'm going to get left with 5 to the power of 4. Now that's going to be my answer. Now what you'll spot is that if logically, instead of having to one by one cross them out, couldn't I instead say write the base down, and instead of going one by one, I can just simply subtract the powers. And so I get, essentially that. Okay, I see Kieran has a question. Kieran, do you want to also ask your question?
So should we start with question 2?
No, not yet. I'm going to just do one more example, and then I'm going to let you get going first. Okay, so now, for this one over here, 3 to the 5 divided by 3 to something. I want to know what is in the chat, what is the power that's hiding over here? Because I'm stuck. I thought that I had to have powers, the bases are the same. Okay, it's 1. Exactly. Now, if I wrote this out in full, we'd all get bored and tired and all that stuff. But what we know is that if the bases are the same, we could cancel one of the 3s. And so my final answer is just going to be 3. And so this law, I call it law 2, basically just says that this, we can subtract the powers. And so what I want you now to do is I want you to try and do G and J. If you are feeling like you're on top of the world, I don't mind you trying M and P as well, but I want you to first try and do G and J. Okay, and you may begin, and let's see what you can do. And then once you've got your answer, just pop it in the chat. I want to see how you guys are doing.
Mr. S. Obaratile asked, what if the bases are different?
Very good question. Okay. in this particular scenario, we can't use this law because this law is only based on a situation where the bases are the same. But we will do a question later which deals with, you can still apply this law if there's some on the top and some on the bottom that are the same, but you can't mix them. So that for now, I want to say just hang in there, we'll get there, but you can only use the strategy if the bases are the same. And there's some more hands, Lebo, who else would like to?
We have a question from Karabo.
Yes. Karabo, go ahead.
Oh, God.
Okay, I'm not sure what's happening there.
I can go
Move on. Fine.
We have a question from Tukela.
Okay, go ahead, Tukela.
What if the exponents are different?
Okay. So the exponents are different in J. So in J, the exponent at the top is 7, and then the bottom it's 1. So what we're looking for, though, is the bases to be the same, which they are. So that's not a problem there. Okay. I put the answers up for G and J. Are there any questions about G and J? If not, I'm going to move on to M and P, which are a little bit more difficult.
Mr. S,
Okay.
we have a question from Lerato.
Go ahead, Lorato.
Lerato, you can unmute yourself and ask your question.
Okay.
Okay. We
So
seem
what I'm
have
going to do is,
lost
I want to
Lerato.
know in the chat now from everyone, why is M a bit more difficult than J? I'd like you to tell me why, if you look at it, why is it a bit harder than the first one?
Mr. S, we have a question from Pumzile.
Okay, Pumzile, go ahead.
Afternoon, sir. I wanted to ask, so once we figure this out, should we leave our answer in exponential form or should we simplify it?
Generally, we'd leave it in exponential form because otherwise it would be too big. Okay, I'm just going to pause on questions for a little bit now, Lebo, just for the next 2 minutes or 3 minutes, just so I explain these two. So I'm looking at the chat and I see lots of students are saying yes. The reason it's harder is now I have not just division, I have multiplication as well. And so we need, in BODMAS, move from left to right. And so what I'm going to do first is I'm first
You're
going to
lagging, sir.
okay. There we go. I'm first going to do the division and then I'm going to do the multiplication. So first of all, what is 7 to the power of 10 divided by 7 to the power of 4? If you could put that in the chat. Okay, so we get that. And then what is left? So we've dealt with this part and we got 7 to the 6, but we're not done. What we need to now do is what is 7 to the 6 times 7 to the 6 going to be equal to? And that's going to be my final answer for M. And you're quite right, we get 7 to the 12. I'd like everybody to try and do P by themselves now. I want to give you a little bit of time because I've kind of given you a bit of a hint. And so I want to leave that to you. And in 2 minutes time, I will answer it. Because it's getting a bit trickier now. There's quite a lot going on in P. Just think about what I was doing in the earlier examples. What ideas can you take from them? Label, do you remember BODMAS from school? What did you learn about PEMDAS? There's so many different ways of saying that
We did BODMAS. I don't know
BODMAS.
what PENDAS is.
the
Yeah.
American one where parentheses are the same as brackets.
Okay.
So
Okay.
parentheses of division. Yeah.
Yeah. Interesting.
Yeah. There's many different ways of saying that. So I think I have to do the thing in the bracket first. So I'm going to do that. And I get that. And then I get, yes. Don't be afraid to ask questions in the chat to everyone. So now I've got that. And what's my final answer going to be? So remember, if you're dividing and you have the same base, what do you need to do? You need to, well, I suppose the first thing is to write down what that base is, and then say 17 minus 7, which gives me 2 to the power of 10, which I think on the whole is being tolerated quite well. Okay, so this is this new law that we've added.
2 to the power of 10.
For the most, yeah, 2 to the power of 10 is the final answer there. Now, I think we need a little bit more practice. Before I move on, if you are struggling, give us a thumbs down. If you're feeling okay and you're like, okay, let's keep moving, give us a thumbs up. Just want to get a quick feel for the group. My impression is that for answers, it's going okay. Yeah. So if it's not going, I want to know. Okay. So for those who are a little struggling a little bit, there are some of us. Can I suggest that now you only do 1 in every 3 questions? So I might be doing 3 questions, but you just focus on 1, and you let a couple of them fall, and you go like, I need to kind of make room for both groups. So what I'm going to say is, if you're feeling very confident, go ahead and do all 5 that are on the board now. But if you are feeling like this is proving tough, I want you to only do these 3 over here. And I'm going to do the first one with you. For the rest of us, anybody else who's feeling like I just want to keep moving, you can go ahead and do the rest of them. So for the very first one, I want you to notice how it's a division question, and are the bases the same? They are. If I did this the long way, 7 to the power of 5 means this. It means times 7 5 times. 7 to the power of 2 means that. If I'm dividing them, basically 7 over 7 is the same as 1. It's equivalent to 1, so it can go away. 7 divided by 7 here is 1. And then what I'm left with is 7 to the power of 3. Now, this is the long way of doing it. Now, what I realized in the previous section was, instead of having to cross out 1 by 1, I can simply say, look, if there's 5 on top and 2 below, 2 are going to cancel out, so I can take 2 away. And so what we did was we used this law that says you take away the powers, 5 minus 2, and you get 7 to the 3. So if you've been struggling, see if you can do E now, and then pop your answer in the chat. I want to see if it helped you a little bit. And then, Lebo, I will take a question or 2 now from students who are needing a bit of assistance.
Okay, Lebongo has a question. I hope I'm saying that right.
Yeah.
Hi, is it wrong if we don't work it out and just like write the answer immediately?
It's fine to do it at this stage. I'm just showing you the whole thing so you understand where it's going. But if you understand it well, you can just go straight to the answer in this scenario. Yeah.
We also have a question from Letabo.
Yes, go ahead.
Okay, Letabo seems to have lowered his or her hand.
Fine,
Kando has a question.
Hello, sir. Hello, ma'am.
Hello.
Hello.
My question is, on division, do we subtract the exponents?
Yes. So you take the top one minus the bottom one. So in this, question K, look at this. I first say, first of all, I check, are the bases the same? If they're not the same, nothing's going to work. If they are the same, so I write it down. Then I look at the power. In this case, it is 7. And I take away what's at the bottom, which is 3. Now, I could also do it the long way, but that would take a lot of time. And because you observe this pattern, we kind of speed it up by using this method. I get that.
Yes, so for
Let's
number
go,
N.
go one at a time. Who's next? Who's next? So
We
I'm going
have
to do
two
Mia.
numbers.
Okay.
Okay, guys, if you ask a question, please raise your hand up and I will call your name. Mia has a question.
Hello, sir. I wanted to ask, if we don't work it out fully,
Hello.
will they deduct marks? Can we do it normally?
Okay. So it's always a difficult question because it depends on the mark allocation. So in question K, I would regard that as a 1 mark question, right? So if you just went straight to the answer over here, you're going to get full marks. It's more debatable in this question over here because it's normally going to be 2 marks. Now, if you suddenly pop up with 5 to the 7, I would say that I would want to see this first step where you get to 5 to the 4 as well for the mark. Does that make sense?
Yes, sir. Thank you. I'm just asking because I'm writing a math test tomorrow.
Perfect. Is it on exponents?
Yes, sir.
Oh, fantastic. Then we will do our best to help you today. Okay. Now, earlier in the, I'm going to give you a chance to do these, but I want to point out something that was asked earlier in the lesson. What happens, in fact, let's really focus in on this one. What happens when the bases are not exactly the same? So what you see here is that there's 2 types of bases. I want to know in the chat, what do you think, how do I handle this situation? I want to know from you, what do you predict the way to handle this is? Or if you're feeling brave, I'd love to hear an explanation from someone who's willing to come on the mic and just turn on their hand. I mean, turn on their hand. Yeah, put up the hand and level will come to you.
Mr. S. Setu has a question.
Okay, go ahead, Setu.
So I wanted to ask, number H.
Yeah.
As the answer is k to the power of 1, is the 1 necessary?
No, you don't have to show it, both are correct. So
Okay, thank
you
you.
could have left it in or it's called deflation about what you
Sorry, my internet was a bit unstable there.
Okay.
There is a question from Charity, or I don't know if they're responding to the answer.
Let's see. Go ahead, Charity. Tando, you're right on the money there.
Hi, sir. Are you
Yeah.
able to hear me?
Perfectly loud and clear.
Okay, I'm sorry. I wanted to answer to the question, but I see you still taking some
No, go
questions
ahead.
also.
Go ahead. Answer the. Are you talking about L?
So what I thought should be done here is that we need to swap the sum to the matching letter. For example, x to the power of 7 and x to the power of 4 above, and then y to the power of 6 and y to the power of 2 below.
Okay,
And
so I
then
think
we're able to compute.
Okay, so there's 2 ways of doing this. I think what you're saying is if you move the y to the 2 above, which is like another law, but for now, are you agreeing with what I've done on the screen? Does that look good to you?
Yes.
So what I did was I took the 4 at the bottom and I kept all the x's together, and then I subtracted the powers and I did them almost separately. And then for the y's, I just kind of did them separately. And so they live next door to each other now. And so my final answer is going to be x to the 3, y to the 4. So that's how we get around this. As long as we've got matching pairs, we can deal with that. Okay, let's try and do, let me zoom out for a second. In fact, I think those other ones, oh no, actually, I think we need the practice. So let's do C, F, I, and O. And then after you've done that, we'll take a little break.
Mr. S. Rabbitway has a question.
Go ahead, Rebecca.
Afternoon, sir and ma'am.
Hello.
Hello.
Sir, I was asking a number and how did you get 5 to the power of 7?
It was at the previous question.
Yes, sir.
Okay. N. How did I get 5 to the power of 7? What I first did was I did the 5 to the power of 6 divided by 5 to the power of 2, and I got the 5 to the power of 4. And then I times that 5 to the 4 times the 5 to the 3. And because the bases were the same, I just added the powers. So does that help?
Yes, sir. Thank you, sir.
Pleasure. Okay, let's see what we can do with this. And then I think we've earned a break.
Rabbitway raised her hand again. Do you have another question or was it the previous one?
Go ahead, let's do questions while students are working.
Rabbitway, do you still have a question? Okay, nothing there. Tando has a question.
So my question, I know it's off topic, but it's about the multiplication. So sir, so with the powers, do we add them when they have the same base, or do we multiply?
Okay. So this is important. There's 3 different laws. If we are multiplying, we're multiplying and the bases are the same, in which case we add the powers. If we are dividing and they have the same base, then we subtract the powers. Okay, so I call this law 1 and law 2. Then the third law, which we had earlier in the lesson and previous lessons, if you have 2 powers next to each other, notice how the base, there's only one base here, or there's only one thing that's at the bottom. Then we multiply. So when the 2 powers next to each other. That's an important distinction. Okay. Cool. I'm sure you weren't the only one who wanted to ask that. It takes a while to get used to that. And especially when we start mixing things together, you'll see that. Okay, so 4 to the 12. We get y to the 6. And then just O is that last one we need to. Yeah, Lebo's giving some good advice in the chat, so don't be afraid to take her advice, and also don't be afraid to ask her a question. She is quite willing to assist you. Maybe sometimes you've been waiting a while to ask an audible question. And
Mr. S, we have a question from Letabo.
Letabo, go ahead.
Yes, so I wanted to ask for number O. Do you do a BODMAS?
Yes.
Then it's division first.
Okay, so in BODMAS, there are actually groups of things that have the same precedence. So addition and subtraction are the same importance, then division and multiplication, and then brackets and or exponents. So because you've got division and multiplication, they're actually the same rank, or they're the same level of importance. So all you do, if you've got 2 operations that are the same level, you do it going left to right. And so in this case, what you're going to do is you're just going to do the division first. You're not doing the division first because multiplication and division are both equally important. The reason you're doing division first is it's going left to right.
Okay, now I understand, sir.
Cool. That's a good question, though. It's a good question. So,
Tiamo, sorry, Mr. S.
Yeah,
Tiamo has a question.
Yeah.
Sorry, sir. So I was asking for number F.
Okay. So what we're going to see, for F, let me just zoom in a little bit. So for F, the main area I can see people could go wrong would be the power of 1. And so what I tell students is if you get confused by looking at it like that, rewrite it so it's written like that. And that might make it a bit easier. Does that help?
Thank you, sir.
Yeah, because now you just go like that. All right, people, I think it's time for a break. And if there are any more questions, I'm going to suggest you stand up and we are going to get some, my roof, not roof, but I need a pen, and so do you. So if you could go and find a pen or a marker, but there's going to be a twist today. And the twist is you're only allowed to use your non-dominant hand. So if you're right-handed, you are going to use your left hand. If you're left-handed, you're going to use your right hand. And it's a variation of what we've done before. You hold the pen. Now I'll give you a little cheat. If you've got a big, thick pen, it's much easier. If it's a thin pen, somehow it doesn't work as well. So that's part of the cheat of why I can do it. The goal is to toss it so it rotates in the air once and you catch at the same end. Okay. So see if you can do that. And it's with your left or weaker hand. Oh, focus close. And then turn your camera on so we can all see and we can decide who's the best at this. Therefore, you can vote. You can decide who the champion is. Okay. Let's go. Who we will crown pen flipping champion for now? Ooh. Okay, I'm getting better at this. Oh, that was the best one. All right, one more time. Oh, practice makes perfect, guys. It's just like maths. You just have to keep practicing, and it's.
Yeah.
Oh, okay. One more. I want to end with doing it properly. Okay, there we go. Oh, all right. I think that was a. Has anybody in the class a brain break that they would like us to try in future, or a funny little exercise? Are there any suggestions that you would like to make before I go back to the lesson? I want to know. All of you have teachers, I'm sure, who do funny little things, or like maybe a funny little stretch. We can get everybody stretching in a certain way. Who has a suggestion? Otherwise, in the next lesson, I want you to come prepared because I want to do something silly halfway all the time, but we need to keep getting new ideas, I think. Anybody? Any ideas? Charity, what's your idea?
Anything.
Yeah. What can we do that's silly that can get our minds to unwind a bit?
I was suggesting that we can take a pen and then put it in a far distance from your eyes, and then in a matter of time just bring it close. No, far distance.
I didn't get that.
I mean that you take a pen and then put it.
So I was just thinking, I wonder if I can balance this on my nose. Oh, there we go. Oh, that's awesome.
Yeah.
So, it's actually tricky, but it's easier the heavier it is. But oh, okay, we can practice that in future lessons.
Oh,
but,
Kanye has it already. Like it's just there. Yeah.
Oh wow, the natural.
Nice one.
Okay, guys. Okay, I've been having too much. I mustn't be too sick. I can get quite sick.
Having too much fun.
So, all right, let's keep going. Okay, we did. I want to practice particular ones here. So I'm going to make. I want to do these ones. Cruising. So that's. In fact, let's just take these three. Sorry, guys, I'm going to be with you right now. I just want to only show you some of the questions as we go. Otherwise, it gets a little bit overwhelming. And so can you all see? Okay, we're going to mix these up a little bit. And for some reason, my internet connection was weak there, so I'll do this again. Let's do it. That's, I'll get rid of, I'm just taking a screenshot so we can focus on that.
Mr. S, while you do that, I see Kieran has a question.
Go ahead, Kieran. Okay, can everyone see the questions? I want everyone to try and do D and G, and then after D and G, I'll go further, but then go ahead, Kieran, and ask a question. And the goal is to simplify these. Yeah.
So I
Yeah.
can't see the screen, sir.
You can't see the screen? Level, can you see the screen okay?
Yes, I can see it. I can see the
You
screen.
might just be, maybe there's just a bit of a lag. So now, what I want to point out now is I'm starting to mix the rules together. It's one thing to know them by themselves. It's another thing to know the laws when they get mixed. And so I want everyone to try and do D and everyone to try and do G. And then when you've done them, to put the answers in the chat. Okay, Mikhail says push-ups. Oh, Mikhail, we can do that. We can try. I think that's not a bad one.
No. Ew.
Like it. I like it. It's good. Your brain. It seems like for the first one.
Yeah, question D is looking good.
Saying 7 to the 20.
Yeah.
Now, what about G? A little bit harder. G is a little bit harder. We need to be careful. And this is where it might be worth checking your answer by doing it the long way as well. So if we go back to the very beginning, to the power of 3 outside means repeat whatever's inside 3 times. And so if you do it the short way, you should be getting the same answer as what you get the long way. Okay, and I can see I've caught a lot of you here because the answer 2 times 2 times 2, which is the number part, is going to be 8. Yes. And x squared times x squared times x squared. I want you to notice how this has the same base. And when the base is the same, we simply add the power. So I go x is the base, and I should get 8x to the 6. Now you may ask yourself, okay, that's fine doing it the long way like that, but how was I meant to use law 3 to do that? So I want to point out how you can do that. What you've forgotten is a power of 1 on the 2. And so if you're using a law where you multiply the powers, notice you've got powers next to powers. What you have to do is the 3 is multiplied by the 2, but the 3 is also multiplied by the 1. And so what you then get is you get 2 to the power of 3 times x to the 6, and 2 to the 3 is the same as 8x to the 6. Or 2 to the 3 is just 2 times 2 times 2. And so we do get the same answer in both ways because maths is always consistent. Okay, give me a thumbs up if that explanation helped. Give me a thumbs down if you still think G is like one of the big mysteries of the universe.
Mr. S, will they be penalized if they leave their answer as 2 to the power of 3 instead of 8?
I don't think you'll be penalized, no. I think when the numbers are small, we convert them to normal numbers. When the numbers are like 2 to the 7, it's stupid to write a really big number. But don't stress. I understand why you wouldn't get this right. In fact, before we move on to G and M, let's just do one more question like this, just to test our understanding. So if I said to you, simplify, simplify that. So I've made up, this is a special one I've made up. I want you to simplify 3x squared to the power of 3. Could you do that for me and put the answer in the chat?
We have quite a few thumbs down.
Okay. So that's why I'm going to rather do one or two of these questions now before I move on, because the moment we start mixing these questions, it's much harder. Let's put our hands up first, yeah, and I'll take a question.
Please put your hand up if you need to ask a question.
I'll gladly.
Uko has a question.
Go ahead, Uko.
Sorry, ma'am, it was a mistake.
Okay.
Okay, no problem. So one of the things you may be asking yourself, why am I going back to the long way if I know there's a short way? It's because I want you to see that the answers are always the same. And so you always have the option of changing back to the long way if you get stuck. Now, the long way here says 3x squared, 3x squared, 3x squared, because it's 3 times. Now, what's nice about this is I can go 3 times 3 times 3 is 27, and then x squared times x squared times x squared. The bases are the same. And so I just write that base down, and then I say how many powers 2 plus 2 plus 2 is 6. If you're doing it the short way, the thing to remember is there's a 1 there. And so now when you have powers next to powers, if you want to do the short way, the 3 is multiplied by 2, and then it's multiplied by the 1. And so the answer would be 3 to the 3 times x to the 6. And then it's a bit of a debate, but normally because the number is under 100 or under 50, you just sort of convert this back to a normal number.
I didn't see this number.
Okay, let's do one more like this because I feel like we haven't quite got it yet. If I say to you, I want you to simplify that, or expand that. See if you can do that. What is 4x squared? Yeah, question, go ahead. Yeah.
Sorry, Tiamo has a question.
Sorry, sir. I seem to be confused on number D. How did you get 7 to the exponent of 20?
Okay, so 7, 4 to the 5. I'll write that question on the side here, just so we can still see this one over here. So your question is, how did I get to 20 when I have this, right? Now, if you wrote that out the long way, do you agree that 4 to the power of 5, the power of 5 just simply means, this just means repeat this 5 times. So 1, 2, 3, 4, 5. And it means repeat whatever is below.
Yes, sir.
So now the base is the same, is it not? And so you add up how many, and that's how we get to 20.
Oh, thank you, sir.
Pleasure. So now let's go back to the question over here. If I was doing it the long way, and the long way is not always worse, eh? If it gets you to the right place, that's what it means. 4 times 4 times 4 is 64. And then we get x to the 6. If I do it the short way, I have a 1 here. And then I go like this. Like this. I get 4 to the 3. And 4 to the 3 is the same as that. Notice how they are both the same. Okay, let's have another vote. Let's see. If you're feeling kind of okay, thumbs up. If you're feeling still very lost on this, thumbs down. Okay. All right. So what we're going to do now is it's almost time for you to go off and do your quiz. But what I want to do, Lebo, is I want to give the poll which says about the pacing. So we're just going to do that little poll which asks the student about how they felt about the pacing today. Now, if you're feeling a bit overwhelmed, remember that there are three lessons before this. And so those recordings are actually on the website and on YouTube. And what I would suggest is that you look at those videos, because you may find you just need a bit of refreshing. And so I think that may be a useful thing for some of you. And remember also, you're not necessarily going to get it straight away. You keep practicing until you get there. Okay, do you want to go and submit the poll out to the students there, Lebo? About is the poll there?
Yes, it's ready.
Okay, go ahead and let's roll it out to the students.
All right.
You'll notice we have a few more choices now. We're a bit more nuanced. And then while they're doing that, Lebo, if you could just see that there is that link for the quiz, so that we have that on standby.
Okay.
Because I think we're going to pass that out to the students in a moment.
All right.
Thanks for your votes, guys. We do appreciate all feedback. Like anything, we're sort of still developing this classroom as we go, and the more information we get from students, the better we can make it for you. And the one thing that's very cool about being on the internet is how responsive we can be. So I really encourage you to do that. And then once you have voted in the poll, Lebo is going to put the link to today's quiz in the chat now, and you can go off and start that quiz once you are done with this poll. And so, yeah, do the best you can now. And so thank you for coming to class this week. I hope you have a lovely Easter weekend. We will see you on Monday. I'm pretty sure that we have class on Monday. And so I will see you then. And yeah, go and do your best in the quiz that you can.